everybody, my name is Clete McGee. Today I'll be giving you my presentation on attention deficit hyperactivity disorder, also known as ADHD, which is what I'm going to call it because that's a mouthful and I don't feel like saying it a lot. To start, why I chose ADHD, I personally have been diagnosed with ADHD. My mom's been diagnosed with ADHD. My sister's been diagnosed with ADHD. My brother probably should be, that's besides the point. Before I get into the presentation, disclaimer. There is no true known cause of ADHD. The particular gene breakdown that I'm going to be discussing only is like 60% accurate in predicting whether or not somebody will have ADHD. So don't go out thinking you know everything about it, because most scientists don't. So I'm just going to tell you what I know and what I found. To start, what is cell communication? Cell communication, or the signal transduction pathway, is made up of three primary steps. First, you see reception here, which is when a signaling molecule, also known as a ligand, comes up. He sees a receptor protein. He says, hey, I want to bind there. The receptor protein says, well, come on in. It binds, changes the shape of the receptor protein, leading us to our second step, transduction, hence the name signal transduction pathway. During the signal transduction pathway is when the protein kinase cascade happens. That is what you see here in this diagram, right? Signaling molecule, ligand, receptor protein. Changes the shape, sends out another relay molecule down to all these other proteins, causes a bit of a domino effect all the way on down throughout a lot of the proteins in the cell, sends out relay molecules, and it amplifies and changes the signal until we can get back to our third stage, response that you see here, which is just when the cell says, hey, I'm going to do what I'm being asked to do. So, what makes ADHD a cell communication disorder? The primary and most important step, in my opinion, of cell communication is reception, because without reception, cell communication can occur because it never receives a signal. So, there are these dopamine receptors in your brain called DR4D. As you see here, I have it typed out all fancy like. So DR4D, it receives dopamine. However, when this specific gene mutation happens, its physical shape is changed, making it less responsive to dopamine reception. So the dopamine comes up to the DR4D, says, hey, I want to bind here. The DR4D says, get out of here, punk. I'm not going to let you bind here. And there's your cell communication breakdown. Reception does not occur. This is a diagram showcasing typical dopamine reception. So there's a lot of different dopamine receptors. Just imagine this says DR4D right here. I didn't have time to change it. And so the dopamine comes out of the synaptic vessel and it walks up to the dopamine receptor and says, I want to bind. Typically, it binds and a signal gets sent throughout the cell. However, in ADHD, in the specific gene breakdown, it comes up to the dopamine receptor and the dopamine receptor does not let it bind. The location of the so-called ADHD gene that I'll be talking about today is 11p15.5, meaning it is located at location 15.5 on the short arm of human chromosome 11. So you see 11p15.2, 15.4, this little purple band at the very tippity top right here is 11p15.5. And typically, it is a 4-allele gene, hence the name DR4D, 4 alleles. However, this specific gene has a tendency to get mutated for some reason. It just does it very often. There's a lot of other diseases caused by this mutation. And it, for some reason, gets a 7-repeat allele mutation, which is kind of odd. And when that does happen, it changes the shape of the DR4D. So, the parts of the brain where DR4D is most commonly found, hence parts of the brain most affected by ADHD. To start is the hypothalamus. The hypothalamus is a part of your brain responsible for covering things like homeostasis. It maintains homeostasis out in the body. And the two most important, typically affected by the DR4D mutation, are sleep, which causes stuff like sleep problems with people with ADHD, and emotional regulation. So you send out hormones throughout your body. Hypothalamus says, hey, we've sent out enough, let's calm down. But when you have ADHD, that doesn't occur. The second part is the amygdala. The amygdala, also responsible for emotions, specifically anxiety and fear, and is the part of your brain responsible for the fight or flight response. This is why ADHD and anxiety are often comorbidities, meaning they get diagnosed together very often because the same part of the brain controls both of those things. And the most important part of the brain affected by ADHD is the prefrontal cortex. This part of your brain responsible for most of your ADHD symptoms that you see. It controls things like planning, decision-making, personality expression, and impulse control. When you put together the failure of all of these parts of the brain, you get to this litany of symptoms here. Things like poor sleep, failure to control emotions, either diagnosed anxiety or at least anxious tendencies. You see mood swings, constant movement. If you know me, you know excessive talking is an accurate symptom to diagnose somebody with. You see poor planning, procrastination. Ms. Fort Mary teaches me, she would know that. And minimal impulse control. So, treatment for ADHD. As I said, there is not one cause for ADHD, meaning that there is not any cure for ADHD because scientists still don't know what specifically causes it. However, if you were to treat it, the best way to do it is by a stimulant. What happens when you take a stimulant is dopamine goes out inside your brain and it's just like, hey, we're a big wave of dopamine. And so the dopamine receptors, which are typically resistant to dopamine, there's just so much, they kind of really pummel the DR4D and it forces the binding. This causes the parts of the brain with the DR4D in it that typically does not function properly for a short period of time. However, the dopamine wears off because your body just kind of gets rid of it because you can't take stimulants all the time. So stimulants are often diagnosed on a daily basis, like you take one a day, you take one every 2 days. I know the medicine I took, I take it every morning. You can take it every 4 hours, that's the way Adderall works, stuff like that. And then statistics of ADHD. This is where you see more holistic, this kind of gets into holistic approaches to treating ADHD. So for ages 3 to 17, which is what's considered the child age, 14.5% of boys are diagnosed with ADHD. However, only 8% of girls are diagnosed with ADHD. And then by adulthood, 55.8% of all people diagnosed with ADHD are males, and only 44.2% are females. But this could also be due to the fact that women typically are better at planning and better at self-control than males are, meaning that you might not see it diagnosed as often, not because women don't have it more often than men, but because they are better at controlling the symptoms, so they never see a reason to get diagnosed. Same with blacks and white children, both have a diagnosis rate of about 12%. However, Asians only see about 4% of their children being diagnosed. Statistically, Asian parents discipline their children more often and more strictly than white or black parents, which could also lead to the idea that discipline in the home and personality expression, things like that, have more so to do with ADHD diagnosis than actual whether or not you have ADHD. All in all, only about 1 in 9 kids are diagnosed and 1 in 16 adults are diagnosed. Awareness, the awareness color for ADHD is orange and the awareness month is October. That's the end of my slides. However, I would like to point out on my board here, as you see, attention deficit hyperactivity disorder. You see this disorder right here. I got distracted while I was putting my board together as true to the disorder. And I ran out of space on my board and I did not realize as I was putting it together. And I got to the very end and I was like, what do I do? And Mom was like, just make it a slant. And I said, okay, that works if it works for you. You see my name here. Also, on the rubric Ms. Fortberry gave us, it said an example of what somebody with your disorder might look like. Exhibit A, I have ADHD, so if you're wondering, Hayes has ADHD. Speaking from personal experience, ADHD is a pretty difficult disorder to deal with, especially as you go throughout your schooling and your education. A lot of teachers, like Ms. Fortberry, will say you might be lazy or talk too much, or that your parents didn't beat you enough as a child. Yeah, but it really is something that's become difficult to deal with as you get to further levels of higher education. As you get older, you typically chill out more, you learn to deal with it. But I know, especially when I was younger, I would always have problems with it. So I will say, if you do know somebody with ADHD, or you yourself have ADHD, just try to be patient with them. I know my parents got on to me a lot for back talking when I was a kid. However, I think they just didn't see my point of view, but that's besides the point. Just somebody with ADHD, be patient. Their brain works differently than yours. I know another cause of ADHD is different brain shapes compared to somebody without ADHD. However, I didn't cover that today in my presentation. But there's just a lot of things behind it. There's a lot of symptoms behind it that might make somebody difficult to deal with. You just got to put up with them because they're going to do what they're going to do. Also, these statistics came from the Center for Disease Control, CDC, so they might be wrong, but I hope the CDC didn't lie to me. Here's my works cited to prove that I didn't make up all this off the dome, and that concludes my presentation. Thanks for coming out tonight.